Hello, dear students. Welcome to the course Robots and Automations RMET 585 685. So, I'm going to start virtual lab 1. So, if I want to introduce first of all the questions, I'm pretty sure you already got these questions. So, I'm just considering this one as lab 1, exploring a virtual robot using RobotStudio. You can consider basically this one is the introduction to the RobotStudio software and a very little bit of work you need to do and submit. So but you can go task by task, but I will mainly emphasize on once you are done, then you would need to use this style to save your file before you submit. So you need to do last name hyphen the last name underscore virtual lab and lab number, and we will continue using the same style for upcoming virtual labs. So yes, if I want to go back to task by task, then you will see first of all we need to launch the Robot Studio software, and then we need to create a new station using some sort of robot, and the robot is especially IRB 760 450 kg 1.3 3.18 meter robot. So why don't I just try to start the Robot Studio software? Yeah, I have both versions. I'm starting with 2024, and then you can put your project name right away here. For an example, Habib Virtual Lab Lab 1, something like this. Uh, and then I would need to find out IRB 760. So if you click there, then you will be able to find out 706. Uh, yeah, this one is a robot. Okay, so if you are using the software for the first time, then it will ask you to download. Your understanding, I didn't use this version, so I needed to kind of click and it will download it by itself. You need to make sure this one is a new one, and the variant 760, I said 450 kg, so you will get that piece, and you will automatically see the robot wire is different versions, but whenever you are using our lab computers or class computers, you may not see that version. I will quickly show how can you download this version as well. So once you're clicking everything, then you need to click create, and then it will take some time, but at the end it will create a station. You will see for the first time it is kind of using this progress, and then you will see this is red for the first time because it is not online, and you will see the status. It was first of all starting, and when you are seeing the green color meaning it is online, then you can use the cursor, the same concept for zoom in zoom out. You can also use your control shift and the left button to rotate from different one location to another, and so now that means you already answered the task one question, or you already finished that one. Now we need to go for task two, like jog a virtual robot as described below. For an example, let's say if you are under the home, then you will see you have multiple options like move and rotate. So if you click there, then if you click this one, then you will see you can use this arrow direction to go forward and backward. You can go left to right, and you can go up and down, right? At the same time, there are three rotation. So you can just click there and you will see these are moving, right? These are moving. For an example, this one, then you can click this, then you will see, or maybe this one, or maybe this one, then you will see this is moving up and down. Still, okay, yeah, yeah. So based on which link and axis you are selecting, you can see it is moving at different direction. So here you will see we have three under the home. We have three sheet. One of them is layout, another is path and targets, and last one is tag. So layout is important because when you are starting with any kind of robot, you will see that brand name here, and if you expand it, you will see all the links. For an example, this one is base, this one is link 1, link 2, so on and so forth, up to link S5. Now, honestly, for the first lab, we are going to mostly use the robot, because every time we will do the right click and we will access different options. For an example, if I go back to the question, then you will see using the mechanism zog join determine the limit of travel for each axis while other axes are at 0. So for an example, you see, you remember, right? I already moved it here and there, and I want to make sure like the robot is again going back to the home position. To do that, you need to do the right click on the robot, and again you need to make sure you are under the layout. You need to do the right click, and you can go move to pose and jump home. Then you will see the robot will go back to the home position. And another what can happen sometime, like let's say for some reason you can really lose that left window. Uh, don't worry how you can find it out or bring it back. You can just do the right click on the home, and you can do default layout. It will come back again. I know it will come back again. Or let's say you want to do another way, do the right click and you can say window, and you can first of all bring layout back, and the same way you can bring path and target back, so on and so forth. So I saw a lot of students normally somehow lost this window, and they get hard time to find or bring it back. So it's easy way. I'm pretty sure it will help you. So once you are making sure you are in the home position, now maybe I can go back again to the question and see what is the next step. Then basically you would need to answer some questions, which is here. I know how many axes does the IRB 760 have. I'm pretty sure if you just go there and go to mechanism jog joint, then you will see the number of axes here. Actually, 1, 2, 3, 4 axes are here, and the next question is what type of robot counter balance does the IRB 760 have? Honestly, I'm not going to answer this question now. You can do some research, or you can talk to me during the virtual lab, then we can discuss and give the answer, or I can give you some hints so that you can find the answer. But right now, I can help you to finish this one, complete the table below. And what I'm saying, for an example, you need to write the axis name and plus limit of travel, minus limit of travel, and total range of travel. So to do that thing, you need to make sure you are under the tab under home, layout, and then mechanisms of joint. You will see those. Now you can see if you do the first axis, it can go from negative 180 to positive 180, right? So if you go back to the question again, so you are understanding what should be the plus limit of travel and minus limit of travel. For an example, if this is plus 180, that one is negative 180, So you are understanding the total range. I saw some student did some mistake previously. They just put the value 0, which is not correct. I'm asking total range of travel, meaning just the absolute value of plus limit and negative limit, meaning 180 plus 180, which is 360, right? So likewise, you need to find out the limit for axis 2, axis 3, and axis 4. So once you are finishing those, then honestly, you are done with lab 1. Now you need to make sure, like, yeah, you can save like this way, or if you think, no, I would need to bring it back to the home position, you can do that. Now the fun part is how you can save it to submit. Then we will always prefer the file called pack and go. Again, the pack and go, and how can you do that? You need to go to file, and you will see there is an option called share. If you click there, then you will see pack and go file. So then you will see this window will come up. Now you can browse wherever you want to put it, like whatever the folder you want to select. And again, I know I started with renaming, but I saw sometimes student will forget to name at the beginning when they're starting the software. So then maybe you can again rename here, but as I mentioned, we would need to follow last name virtual lab 1 this style. So once you're selecting this thing, you can do save and okay. Then it should save as a pack and go file. And if you want to check that thing, then maybe you can quickly go and to the location. For an example, for my case, you will see this one was the file I just saved. So once you are finishing that part, yeah, but at the same time, you need to do multiple save, because saving is good, but I will really prefer pack and go more, because you can just simply take that file to any computer, and you can open wherever you just stopped your work. So and it is great, because sometimes you can save a wrong file, or you can really lose your saved file, where back and go will always start from the state you stopped at that time. So I hope this helps. I will bring another video for lab 2. Thank you.